Greetings, welcome back. There was some alterations. So this is an injury, this is a pimple, and I got a green screen. How cool. Oh, I'm everywhere. Okay, the injury was actually caused by a villain. This villain. I ran into this rectangular hollow section in the dark at nighttime in my shed, and I was like, I was struck down, but not even by something cool. It was such a basic design. I could do this in like 5 minutes, and I was like, that's a great video. We should totally design this thing in 5 minutes. Well, maybe it might take a little bit longer because I'll take time to explain things, but let's model a rectangular hollow section. So here it is. Here's the villain that struck me down. It's just a simple set of really 3 unique rectangular hollow sections welded together. We got one rectangular hollow section there, a second, and a third. And these legs are all the same. But I thought we might make the video a little bit interesting. Let's go ahead and we'll also make a drawing of it. So if we have a look here, we'll have a drawing. It'll have a parts list. We'll be able to see the welds, and we'll even have separate sheets for each of the parts. So it should be very straightforward. Let's get to it. So we'll begin by starting by creating a new design. It's been a while. We'll come along here and we'll click File, and we'll click New Design. And what we're going to do is we're going to make the 3 rectangular hollow sections that make up this assembly. So we'll go ahead and we'll start off with a sketch. I'm just going to close the data panel by hitting the X here. We're going to click Sketch here, and we'll click on one of the vertical origin planes. Let's say this one, the XZ plane. Next, we're going to make a center point rectangle. So to do that, we'll come up to the top left, click Create, find Rectangle, and choose a center. There we go. And hit Escape to get rid of the tool. To add the dimensions to this rectangular hollow section, all we need to do is come to Create, Sketch Dimension, and pick one of the edges. Click once, and then click below it to place the dimension. So this one is 25 wide, that's millimeters, not inches, and 50 tall. Now, I happen to have measured it, and it's actually 0.5 millimeters thick. So what we need to do is we need to make a rectangle that's offset 0.5 millimeter inwardly. Now, we could go ahead and we could draw another rectangle if we wanted to and, put in the dimensions as before, but we're all about being lazy. So let's go ahead and use an offset. Here we'll come along and click Modify, Offset. And then we'll click the edge. And here we can click and drag it inward or outward. Let's go ahead and drag it inward and type in 0.5 and click OK. And now we have the section drawn. Click Finish Sketch. And now what we're going to do is we're going to rotate our view. So holding down Shift and the middle mouse button to rotate the view. We're going to extrude this out in both directions. So to do that, you hit E for extrude. Otherwise, you can click the extrude button here. And go ahead and select the profile. So you might have to zoom in with the mouse wheel. Select the profile. Zoom out again. And now see this blue arrow? If you click and drag it, we can drag it out into the 3rd dimension. Now, let's go over to the extrude dialog over here. At the moment, it's set to going in one direction. Let's go ahead and change that direction from one side to symmetric. And now we'll change the extent type. Yep, we'll keep it at distance, but we'll change the measurement from half of the length to the whole length. So click whole length. And now we can type in here the distance, the length of the rectangular hollow section. So this one is 1,100 millimeters of evil. What the symmetric did was it forced it to go in both directions equally. If we chose one side, it would just shoot out in that one direction, but if we choose symmetric, we can keep the origin at the middle. That's going to be useful for later. All right, so we'll keep the operation as new body and click OK. Lovely. Okay, what we're going to do is hit save. So save early, save often. Go ahead and click the little diskette in the corner, save. And let's give it a fitting name, the rectangular hollow section that jabbed me in the face and deformed me for life. I'm kidding. Go ahead and hit save. Okay, and now we'll have a look at our design. If we expand out bodies, we have a single body there. That's going to be our first rectangular hollow section, but at the moment it's just a body and we haven't turned it into a component. We'll do that a little bit later. Next, what we're going to do is do the rectangular hollow section that comes horizontally here. So to do that, we'll come along to create sketch. And because everything is centrally aligned, we can take advantage of that. So let's go ahead and pick the central vertical plane here. So this is the YZ plane. And create a sketch on it. Next, what we want to do is make a 2-point rectangle arbitrarily in space. So we'll go ahead, click once, and click again. And hit escape to get rid of the tool. As before, we're going to add in the dimensions. And we're going to use the hotkey for dimension this time. We'll hit D for dimension. So hit D, select one of the lines, and here we can put in the dimensions. So we'll say, oh, yep, that's correct. Cool. So for this line, we'll make the dimension 25 millimeters. It's 25 millimeters wide. And for its height, it's 50 millimeters tall. So dimension, that line there, 50, delightful. Excellent. Now I'll show you, yeah, that looks good. It's just as tall as the other one. Excellent. So there's a few ways of connecting this box to that box. But I find that the laziest way is as follows. What we're going to do is we are going to project this line. That is to say, we're going to grab that line that is that edge of the box and bring it into the sketch. So to do that, we'll come along. You can hit P, otherwise you can hit create, project include, and hit project. And then click that edge there. And click OK. Now, because they're the same dimension, there's nothing stopping us from clicking and dragging it over. But if we wanted to do it properly, just in case in the future some dimensions change, we're going to make it constrained, the center of this line to the center of that line. So to do that, we'll come along to the midpoint constraint. And what this will do is it will select a midpoint of a line or a point and connect it to a point or a midline. So we'll go ahead and click midpoint, select this edge here, and this edge here, and it will connect the center of those two lines together. And now we have the rectangular hollow section. Well, it's not actually an RHS yet. We have to do our offset trick as before. So let's go ahead, we'll create an offset, hit O, or alternatively modify offset. And now we'll select that rectangular hollow section, the box here. Sorry, it's a bit late. All right, we'll click the box here. Delightful. And as before, we can click and drag that and make sure that it's 0.5 millimeters inside, like so. Good stuff. And when you're finished with that, make sure all the dimensions are in place and click Finish Sketch. Excellent. Okay, let's rotate our view, and here we can see the sketch is on the mid plane there, and it happens to touch our previous rectangular hollow section. So next, we'll come along and we're going to extrude as we did before. So hit E or the extrude button. Carefully select the profile we just drew. Click. If you accidentally select too many, like both of the profiles, you can unselect one by holding Shift and selecting it again. Great. And here, let's go ahead and we'll change as before the direction from one side to symmetric, which will make it extrude out in both directions equally. And also, here we're going to change the measurement from half length to whole length. Click. And we're going to extrude this out. And its total length is 110 millimeters. Is it? I can't remember. I believe so. Let me just measure really quickly. The whole length is 280 millimeters. I might have been a little bit wrong. But don't click join or OK just yet. Be careful. We have a look at this rectangular hollow section and we can see that it's joining to the previous one. Maybe that would be the dream situation if we could magically weld them together, but at the moment they're meant to be separate components. So what we're going to do here is come to operation and we're going to change it from join to new body. We could skip a step and create new component directly, but we'll create all the bodies first and then turn those bodies into components a bit later. So go ahead and click new body, and there you will see a line between them. That means that the faces aren't joined, they're separate bodies. And we'll click OK. Delightful. Okay, so if we review our bodies list, here we've got body 1, excellent, and body 2. Great. Now, there's one more villainous rectangular hull section that makes up this assembly, and that's this little leg here. So it's a 40 by 40 piece. We're going to go ahead and we're going to model that now. Interestingly, it's asymmetric, so it goes up a little bit, but it goes down quite a lot. Its total length is 110. Don't hit me again. Okay, let's go ahead and we're going to do that. We'll say create a sketch, and we're going to create a sketch on the ground plane here. And this is one of the advantages of having the assembly centrally or aligned. It doesn't need to be, but it's just useful. So we'll go ahead and we'll create a sketch as before, and we'll repeat the same steps as earlier. So what we're going to do is we're going to project this edge here. This time we're going to use the hotkey P. So hit P, and then click this edge here. Dook, and click OK. Again, we'll create a 2-point rectangle, and we'll click. And before clicking the second time, here we can type in the dimensions. So we might say 40, tab 40, and hit enter. And there we've got a 40 by 40 square. Next, we will constrain it so that the midpoint of this line here is connected to the midpoint of this line here. And we can do that by using the midpoint constraint. So as before, we'll click midpoint, click this line here, and click this line here. And now click connected. Excellent. And I'm just going to double check that it is indeed centrally connected, just making sure that the dimension here, there we go, 7.5, equals the dimension here. 7.5. If you want to, you can create that dimension, although because it's over constrained, it will just create a driven dimension, which is a fancy way of saying it's just reading whatever dimension is there. Good. Okay. And as before, we're going to create an offset. So we'll say O for offset. So click O, select the little square, and we're going to drag it in 0.5 millimeters. Excellent. Great. Okay, and finish sketch. And this time, we're going to do a slightly asymmetric extrusion. So as before, we'll click extrude, and we'll zoom in and we'll choose the little profile, click. And here, what we're going to do is change the direction from one side to two sides. And here, what we can do is now we're presented with two arrows. We can drag one up a fixed direction and the other down another direction. So we might go ahead and we might drag this up, say 35 millimeters. And for the side 2 here, we might say down 45 millimeters. There we go. And as before, change the operation from join to new body. So make sure you change the operation to new body. Great. Okay, click OK. Okay, lovely. So remember, go ahead and hit save. Save early, save often, always save. Here we have 3 bodies, which make up the 3 unique rectangular hollow sections that make up this evil assembly that hurt my face. We'll go ahead and we'll see body 1, body 2, and body 3. We are going to repeat body 3 a few times to make up the other legs. We're going to repeat body 2 twice to make up the lateral beams. But first, we're going to turn them into components. So quickly, what is a component? A component is just another part. So there's no specificity as to whether or not a design in Fusion 360 is a single part or if it's an assembly. A single design might have just a single body in it, in which case you might say it's a part, or it might have several components in it, which then you would regard it as an assembly. But if you want to make a parts list at the end of the day, it's best to have a bunch of components, and that's what we're going to do. So there's an easy way to do this, and easy is lazy and lazy is efficient. We'll go ahead and we'll click right-click bodies here, and what we're going to do is turn those bodies into components. So right-click bodies, And we'll go ahead and click Create Components from Bodies. Wunderbar. Okay, so here we've got Component 1, Component 2, and Component 3. And now let's go ahead and give them names. So to do them, gently double click them. So click, click, and we'll rename Component 1 Rectangular Hollow we'll call it Section A. Excellent. And then Component 2 we'll call Section B. Great. And Component 3, Section C. Excellent, excellent. Okay, now before we continue, a word of warning. Now that the components are created, they're not fixed in space with the exception of the first one. So this one, if we try and click and drag it, nothing will happen. But if we grab Section B, whoop, it will move. Or Section C, whoop, it'll move. No good, terrifying, horrible. We're gonna go ahead and revert their positions by clicking here, revert position. Excellent. Okay, so what we need to do, there is a lazy way of constructing them. I will show you that a little bit later, but we'll do it the proper way first. What we want to do is we want to make sure that this component is fixed with this component in a way that we intend them to be fixed together. So we'll come along here and we'll say assemble. And here we'll say joint. J is the hotkey. And we'll go ahead and we'll click on this surface. And what we want to do is we want to select this point here. I find it useful to hover over a surface first and then hold down Control. And what it'll do is snap to points of interest. Do you see that? So there we go. So we'll select this point of interest. And then we'll hover over this section here. And again, hold down Control and select that point of interest. Wunderbar. And when you click, half of the time it'll wildly fly out of control and be no good. So now we've got to play around with the nature of the joint. All right, so what we want to do is we want to, in this case, I can see that it's flipped upside down. We want to click the flip button. There we go. And now it's in its proper position. It's possible to add in offsets here, but we don't want to do that. We just want to make sure that the center of this is connected to the center there. Delightful. If you go to the Motion tab, here you can see what kind of joint it is. At the moment, by default, it's rigid, which means it's fixed together. If you hit this little play button, it will give you an animation as to what a rigid joint looks like. If you change the type to, say, revolute, it might be a revolving thing like a wheel, but it's not an axis in this case. So we'll go ahead and change it back to rigid. That's good. And we're happy with that. Excellent. Good. Okay. And we'll click OK. And now we've got a joint in there, and you can see it and you can edit it if you want to by right-clicking it. You can also see it in the joint tree here. If you expand it out. There we go, rigid one. Okay, next what we want to do is we want to connect this leg here to the body. Now I'll show you the lazy way. I would discourage this way because sometimes it can go wrong, but it's not the end of the world. Like you can use, say, for example, like say that you use the align tool to get something into position. So say that you would come along to modify and you would just say align. So the hotkey for me is A. You might say, yep, align this face with that face and it will line them up and you get them into position and then you can capture the position and then you can do what I'm about to show you. But it's a lazy way. I just undid what I did. What I'm about to show you is a way of saying to Fusion, hey, however you've got the parts now, make a joint, make it like that. So to do it, you'd say assemble and you'd say as built joint and you select the parts in the position that they are and it will just fix them. Now they're fixed together and they won't move. There are opportunities when, if you're careful, you can use that, but I like to be a bit more explicit when it comes to my placement of parts, of components, joints. All right, so what we're going to do is, the first thing we're going to do is we're going to do a measurement. So we're going to inspect, and we're going to, well, hit I, or the measure tool here, and we're going to get the distance from this surface here to this surface up here. And we can see that there's an offset of 10 millimeters. Great. We also see that they're centrally aligned here. Great. So as before, we're going to create a joint. We'll come along here and say assemble, and we'll say joint. And now we're going to select the point of interest. So here we'll hover over the top face of this rectangular hollow section, and hold down Control and select this central point here. Click. And now we're going to do the same for this surface here. A little bit harder to see, you have to zoom in, but hold down Control and then select this little point here, central and outer. Great. And as before, we're going to have to flip so that the joint makes sense. There's one more thing that we need to change. We are going to have to displace this 10 millimeters upwards. So that's what we measured. So to do that, all we need to do is click and drag this arrow here. Whoop! It went in the other direction. Click and drag this arrow down. And we'll say negative 10 millimeters is the displacement. And that way we're creating a gap of 10 millimeters from the top surface here to the top surface there. Done. Go ahead and click OK. And now we've got a joint formally constrained. Wonderful. Save with a Control S. And we're going to quickly do the remaining components. So let's go ahead. We are going to make a duplicate of this rectangular hull section and put it on the other side. And then we're going to make 4 of these legs. So we like to be lazy. Let's go ahead, rather than creating a whole new component and defining its unique characteristics, we are going to copy and paste like legends. Let's go ahead and select section B here. And literally Control C and Control V, copy paste. And you'll see a bunch of arrows show up. This is our pasted copy. We're going to drag it roughly into position. Doesn't really matter. And now we're going to create a joint. So as before, we'll create an assembly joint by clicking J. Select the top face of this beam and the top face of this beam. And once again, without fail, it managed to screw it up. We will go ahead and click flip. And yay, that looks good. Excellent. And hit OK. Lovely. Now we're going to do that a few more times for section C because this thing has 4 legs. So we'll go ahead, we'll select section C from the list, Control C, and here you can paste it 3 times. So 1, 2, and 3. The positioning doesn't really matter. We're going to create joints for them all anyway. Okay, next, let's go ahead and make a bunch of joints as we did before. So we'll click J for joint, and we'll select the top face of this rectangular hull section and the top face here. And as before, we'll flip and we'll use our offset. So negative 10 millimeters. Great. Pan over and we'll repeat the process for the others. So there we go. And that face there. And we'll flip it and offset 10 millimeters. Great. And last one. We'll go ahead and click this face here and this face here. And we'll flip it. There we go. Great. And make sure that you've got an offset, negative 10 millimeters in my case. Great. Yay. Excellent. Okay. Wonderful. Good. Done. Excellent. I said 5 minutes and I think it's already slain me. All right. So what we're going to do is we are going to firstly hide the joints and we are going to save. So what I'll show you next is a few things, how to change the material of our components, and then look into the metadata a little bit. And that's going to be a bit more useful when we create a drawing. So first thing, let's go ahead and change the material. So to do that, we'll click Modify. And here we'll say Physical Material. Now, this happens to be mild steel, I know, because there's rust on it, and yeah. But say that we wanted to change it to aluminium. What we could do is we could find aluminium in the list. So we'll go down to metal and we'll find aluminium 6061. Yep. And here you can click and drag it over to the components. So we'll click it and drag to the central section there. And then one of the 2 lateral sections. And you'll see that when you make one of them aluminium, they'll both turn aluminium because it's both the same component. And again, with the vertical legs. So that's how you can change the material. But I'm going to hit undo because it happens to be mild steel, which is exactly what it is. So I'll hit undo. So Control Z, Control Z, Control Z. Excellent. Great. All right, hit save. And next what we're going to do is we're going to look at the metadata of the components. So to look at the metadata of section A, we'll go ahead and right click it. And here we'll click properties. Okay, and what we can do is here we can see part number, part name, description, material, and useful things like mass, volume, density, area. These things are really, really useful. So say, for example, this evil design here, it's powder coated. So the powder coater says, what's the surface area? And rather than doing maths and being fancy about it, here I can just retrieve it from the model. I happen to know that it's 3.257 times 10 to the power of 5 millimeters squared. It's millimeters squared because Autodesk is American software and they work in imperial. So when they go to ISO, there's just assuming millimeters squared is the area. That's okay. That's okay. Just be aware of it. And we've also got the mass, so about 638 grams. Yep, makes sense. Good stuff. Excellent. Okay, description. What's this for? What we're going to do a little bit later is we're going to make a drawing, and in that drawing we're going to have a parts list, and in that parts list we can pull up things like the mass, but we can also pull up the description. And this is really good if somebody is ordering these sections, to make these designs in bulk. What they'll want to do is go to the parts list and see the description. They might go over to the drawing and see the measurements to double check, but the description should capture it. So here for section A, let's add the description. RHS, so rectangular hollow section, and we'll put 50 by 25 by 1100, so 1100 millimeters, times 0.5. That's the notation I use. If you use something different, let me know in the comments. But yeah, rectangular hollow section, 50 millimeters by 25 millimeters by 1.1 meters long by 0.5 millimeters wide, which pretty much captures all the devilry of this design. Great. We'll go ahead and click close. And what we're going to do is repeat that process. I'll just make sure that that's saved. No, it didn't save. Luckily, I copied it. Hit paste. And this is important. Don't make the mistake that I did. Click away from that and then click close. For some reason, it sometimes struggles to save unless you do that. I'm just checking. Yep, it did it. So just click away before you close. We'll repeat the process for section B. So we'll come along to section B and we'll right click it and we'll say properties. And now for the description, we'll put in rectangular hollow section RHS 50 by 25 by 280 by 0.5 millimeters. Now, in my professional life, I've actually been caught out by this before. It might be that you up-rev the design, you change the design, you make it, 280 millimeters to 310 millimeters. And you have to remember to change the description, because if you don't, and they are ordering from the parts list, then they might order the wrong component and then you'll be in trouble. So don't do that. But yeah, here we go. So we'll go ahead and click close and we'll repeat the process one last time for section C. Right click and click properties. And again, we'll say RHS, and this time space 40 by 40 by, I didn't measure it. Let's go ahead and measure it quickly. 80, I knew that. I was just testing to see if you remember that. Section C, there we go, properties. Great, 40 by 40 by 80 by 0.5. And then make sure you click away and then click close. Excellent, excellent, good, excellent. Okay, go ahead and hit save. And there we have our assembly. At the end of the, after we finish the drawing, I'll show you how to come back and export these as step files, which is also very, very useful if you're handing it over from manufacturer. All right, so to make a drawing, we'll come along to design and we'll come down to drawings and we'll say from design. And what we want to do is we want to make a single drawing with many sheets. Well, we're just going to do two because we're lazy, but the first sheet will be the assembly and the parts list and maybe show a weld or two. And the next sheet will be one of the rectangular hollow sections in detail. So we'll go ahead and we'll say full assembly. There we go. And create drawing. On your screen, it may just be create new, and the template will probably be from scratch. I happen to have a template here. I might make a video on how to create templates sometime. Yep, and we'll say okay. And now, yep, sometimes it lets you place down the first view, sometimes it places it down automatically. We'll go ahead and here, hit escape if you haven't already. You'll have a view placed down on the page. What we want to do is we want to make some projected views. So we'll come to the top left and click projected view. Click our base view. And now we can place one below, to the side, and I like to throw an isometric view in the corner there. And hit enter, okay, to click it down. Now you can change things about these views. So say for example, like you might say, we want to change the view to show hidden edges. In this case, I'm just going to leave them as visible like that. But I will change the isometric view to be shaded. So double click the view and hover your mouse near the view, double click. And here you can change the style. Here we go, from parent, visible edges, hidden and visible lines, and shaded. Go ahead and click shaded. There we go. And click close. Lovely. All right. And next, what we're going to do is we are going to create a parts list. Well, technically, yeah, a table. So go ahead and we'll click table here. And now we'll go ahead and you can snap it to the corner here, but we're just going to place it here for the moment. All right, place down your parts list. And the first thing that you'll notice is that these friendly bubbles show up. Fantastic, excellent, very good. Sometimes you just rearrange them so that you're happy. These bubbles point to the parts in your assembly. But what I'm going to do is delete them and show you how to create them manually. I like to put them on the isometric view anyway. So here is the parts list, and here we see item 1, item 2, and item 3. We've got the quantity. So for item 1, which is section A, there's 1. For section B, there's 2 units. And for section C, there's 4 units. What we're going to do is we are going to put down new balloons, and we're going to put them on the isometric view. So to do that, we'll come along to balloon, click, and then go ahead and just select one of each of the components. So we'll say that one there, place down the bubble, and here, place down a balloon, and here, place down another balloon. Delightful. So item 1, item 2, and item 3. And hit escape. Okay, there's a lot of nuance to this. You know, if you've got multiple fasteners down a hole, you can stack them up, but that's another video for another time. Let's go ahead and play with the parts list. So this parts list, it's a little tricky to click and drag around, but if you click near the border, you can then click and drag it around. If you double click it, here you can change the fields that the parts list is are including. So by default, you've got item, quantity, part number, and material. You can tick mass, for example, and it will retrieve the mass of that component. That can be really, really useful sometimes. Other times, I will just untick mass. Alternatively, we might want to add description. So this is the description that we added earlier in the metadata of the part. It's retrieved on the parts list. How useful. We'll go ahead and click close. And like in other programs, we can click and these little lines, these little corners of the cells, and we can just adjust the cell width so that it's all nice and neat. There we go. Great. So we've got a parts list that shows the item number, the quantity, part number, description, material. Maravilloso. Perfect. Excellent. All right. So we're going to click and drag it into the corner. So click the edge, and we'll go ahead and we'll drag the corner into the corner of the drawing. Very neat. Excellent. Wonderful. Okay, cool. All right, hit escape. Next, for these overview parts list things, I also like to add in overall dimensions so that when somebody's assembling it and they want to say, is it as wide or as tall or as long as it needs to be, they can check here. So let's go ahead and we'll add in dimension. So D for dimension, just like in a sketch, or click this button here. And we'll go ahead and we'll click the top edge here and the bottom edge here. And there we've got the total length. We'll do the same for the width. So edge here and edge here. Boop. Great. And one more for the height. Edge here and edge here. 80 millimeters. Wonderful. Excellent. Okay. That's good. The last thing to do for this sheet is to add in the information in the title block. So here, my template is pretty straightforward. You've got client and date and you've fields below. So if you double click on the title block, you can add in the fields. So for client, we'll say YouTube friends. For the date of issue, we'll say today. I think it's the 24th. Should probably know this. I live in the world. 24th. And here, the rectangular holder section that jabbed me in the face, we might say assembly and parts list. Your standards might require you to do everything in capital letters. Probably should do that. All right, for revision, we'll say revision 0. I like to start with 0. I will die on this hill. Starting at A or 1 is for barbarians. Okay, cool. All right, so we've got the first sheet. Go ahead and hit save and save the drawing. It'll be in the same folder as the design. Hit save. Okay, now if you hit the button at the bottom, quick add, you can add a sheet to this, but I'll show you a far more artful way of doing it. So what we want to do is make a single sheet that dimensions one of these components. We'll just choose a simple one. So let's go ahead and we'll go back to our design. And this time, let's go to section B. So this lateral component here, and we'll right click and let's go ahead and say create drawing. Okay, now stop, don't hit OK. Don't rush. I always rush. What we're going to do is we are going to say, where it says drawing, change it from create new to select the drawing, the rectangular whole section that jabbed me in the face. You have to have the drawing that you want to add the sheet to open. Don't close it. If it's closed, you won't see it in this list. But if it's open, you'll see it in the list. So go ahead and choose that drawing that's open. And for the sheet, you can add the view to an existing sheet, or you can create a new sheet. So I'll say create new sheet and click OK. And ta-da! Now we can place down our base view. Click OK. And if you look below, there's our first sheet and there's our second sheet. So there are multiple sheets in the same drawing. There are situations where you might want a unique drawing for each part, especially if the parts are complicated. Whether or not you have all of the, components detailed in individual sheets in a single drawing or a separate drawing for each component really depends on the size and scale of your design, as well as the practices of your company. In this one, I'm just going to do them all in one drawing, just to show how it can be done. So as before, we'll create projected view, and here we'll choose this view here, and we'll place one below and one to the side, and an isometric view, and hit enter. Now the scale is a little bit off, so let's go ahead and we're going to change the scale. So hover near the view, double click, and here we'll change the scale. So at the moment it's 1 to 5. Let's go ahead and change it to 1.2. That's better. And now we might go ahead and add in dimensions. So you might say dimension there for the length, dimension here for the height, and dimension here for the width. Now this is very skinny. I honestly would just go ahead and put in 0.5 millimeter dimension for there. But yeah, if you really want to show the detail, you can come along here and click detail view, click an edge, click the view, click the edge, place down the view and put down probably a big scale like 3:1. Boop, there you go. And you can really show the dimension up close, although probably not necessary for this one. Okay, cool. So we've got our drawing. Make sure that you update your title block. So this is section B, and hit OK. Finish properties, and we'll go ahead and we'll save that, and done. I forgot the weld. I'm going to add in the weld now. I'll show you how to add in the weld now. So navigate over to your drawing and come over to symbols. And here you've got different kinds of symbols. So say, for example, surfacing, and you've got taper and slope. Go ahead and click welding here. So click welding. Click the component or edge that relates to weld and the corner that it's applying to. And then click down and right click and say continue. And here you can place down your weld detail. So you might say it's a fillet weld, and you might say its penetration depth is 0.1 millimeter. And add in all your fancy welding descriptions. So is it intermittent? Is it flush or concave and whatnot? Okay, cool. Edit over. That's how you do a weld. Bye. Okay, before we wrap up, I'll show you how to export the drawing as a PDF file and show you how to export the components as step files. So we'll go ahead and we'll click Export PDF in the top right-hand corner. We'll say All Sheets, click OK. And here we'll give it the name, the rectangular hole section that jabbed me in the face, And for the location, you can save it on the cloud or you can save it onto your computer. I'm just going to choose the the folder that this is in. Hit save. And we'll go ahead and we'll come to rectangular hollow section. And here what we're going to do is we're going to export the whole assembly as one big step and then a single component as a step file. So we'll go ahead and we'll choose the entire assembly. So just close the data panel first, choose the entire assembly, click export, and then come along to choose the name. So I just like to delete the version at the end, change the type from Fusion file to step file, choose the location, and I like to add in the revision rev 0 and click export. The same process goes for the components. So we might say find section A here, right click it, and we will say export, and then say section A, and then suffix it with rev 0, and say export. Delightful. And if you go to the folder, I'll just go ahead and I'll find it on my personal. There we go. We've got the step files and the PDF that got created. Whew! All right, that was a bit more than 5 minutes. It got to strike me down twice. Damn rectangular hollow section. It was a lot of fun to finally make a video again. Sorry for the delay. I'll put something fun on the green screen. Hopefully it was good. I just didn't want to clean the house. Anyway, thank you for watching the video. I hope you learned something good. If you have an idea about what you want to see in the next video, please put it in the comments below. If you have any trouble, please reach out. Enjoy the 3D modeling. It really is the best part of engineering. Have fun, and I'll see you next time. Bye.